Hey guys, so today we are going to be talking about triangle constructions. So we are going to look at angles and we're going to look at side lengths, and we are going to try to determine whether or not we can construct a triangle given those constraints. So at the very top it says, when given certain angles and side criteria, you may be able to form one, many, or no triangles. Okay, so we are going to look at a couple different examples and try to form triangles. So the first one, a side length of 4 centimeters and a side length of 5 centimeters that meet at a 60-degree angle. So I usually try to always start with the longest side. So you definitely are going to need a protractor and a ruler, so make sure that you have one handy. So I'm going to just use the protractor for now because there are up to 10 centimeters on the protractor. So let's measure out a 5 centimeter line. So the centimeters are on the inside, so if I do that, I'm drawing a line 5 centimeters. Okay, so it's saying 5 centimeters and 4 centimeters that meet at a 60-degree angle. So if I do that, I need to then measure my 60-degree angle. So I don't know if you can see this, but the end of the line that I just drew is centered around that circle. So that's going to be my vertex here in just a second. And I need to determine where 60 degrees is. So 60 degrees actually is up here. It's going to give me an acute angle. So I'm going to put a little point there. And although my line's not going to go up that far, it gives me an idea of what that angle should look like. So now I need to line it all up. So that is the direction that it is going in. And actually I can just go ahead and draw this line. So this is at 5 right now and 1 is down here. So I'm going to draw it so that, oops. There we go. Let's just measure and make sure that that is 4. Actually, it's going to be like right here. So it'll end right there. And then when we connect those two lines together, we have a triangle. Okay, so this was 5 centimeters, this is 4 centimeters, and this was a 60-degree angle. Okay, so I measured that, drew my angle, and then measured my other remaining side. Anything that is kind of left over you can erase to make it look real nice and neat. So that was number 1. Okay, so for number 2, we are looking for a triangle with two 45-degree angles. Now, for this one, it doesn't really matter the length of that side, so I'm just going to draw a line. We'll stick with like a 5 centimeter line. So there's that. Okay, now you are going to have to draw out and measure a 45-degree angle from both ends of that line. So 45 is going to be halfway in between 40 and 50. So if I do that, I put a point here and I can draw my line. I'm sorry if I have to kind of move this around a little bit, guys. It's trying to get precise measurements. Okay, so that is a 45-degree angle. And then this one is also going to be a 45-degree angle. So halfway between 40 and 50, if I draw my line, and there we go. Okay, so that's a 45-degree angle, that's a 45-degree angle. And then up at the top, obviously we don't need this overlap. So there's our triangle with two 45-degree angles. Okay, so when we look at number 3, we're trying to create a triangle with sides 3 centimeters, 5 centimeters, and 10 centimeters. Okay, so we can try this. So let's start with the longest side. Okay, so 10 centimeters is going to be all the way across on your protractor if you're using the same one that I am, which you probably are. So 10 centimeters is right there. Now, if I take my remaining two sides, 5 and 3, and I try to draw lines, we know that it's going to have to be definitely, they're going to have to be acute angles with the sides pretty close to that 10 centimeter line. But actually, if we try to draw this, no matter what, if we have, even if we, let's say, okay, so that's my 5 centimeter line, right? Even if I tried to get this as close as possible to that 10 centimeter line, this triangle would actually never work. So the sum of these two sides has to be greater than that 10 centimeter side. And since that is not possible, we're just going to write not possible. Now, in order for this triangle to work, this would have to be at least 6, right? Because we would need 5 plus 6, which is greater than 10, to give us 11, and then that triangle would work. But for now, not going to work. Okay, so let's take a look at number 4 then. Okay, for number 4, I'm actually going to use a compass. So if you have something that you can use as a compass, that's really helpful. If not, you can do this without a compass. I just think it's more helpful with a compass. Okay, so for number 4, we're drawing a triangle with sides 5 centimeters, 7 centimeters, and 9 centimeters. So once again, I am going to draw my 9 centimeter line. Okay, so that is 9 centimeters. And then I need 2 remaining sides, one with 5 centimeters and one with 7 centimeters. So what I am going to do is I'm actually going to take my compass, okay, taking my compass, and I am going to measure out 5 centimeters and then measure out 7 centimeters. So if I look at, we'll do 7 first. I'm going to put my point that does not have the pencil attached at 0, and I am going to put my other point at the measurement that we need, so I'm going to put it at 7. Oops, this one does not, okay, there we go. Alright, so that's 7. So now, if I'm doing this, I'm actually going to draw an arc. So I don't know, the arc is just going to look something like this. And once again, we will erase these lines later. We're trying to get an idea of where these are going to intersect. Okay, so 7 centimeters is going to be off in this direction, and we're going to do the same thing for 5 over from the opposite side. So once again, I'm going to measure out 5 centimeters with my compass. So my point that does not have the pencil attached is at 0. My pencil is at 5. And now when I do this, I'm going to draw another arc over here. Okay, so we notice that there is a point in which these two lines intersect, and that will be where those two lines for those legs of the triangle will actually join together. So if I take my ruler, now I have a perfect 5 centimeter line from this vertex on your triangle, so that's 5 centimeters. And then this one is also going to be a perfect 7 centimeter line because we use that compass. So like I said, if you do not have a compass, no worries, you can totally do this. Oh, I didn't line that one up very well. Okay. Yeah, like I said, if you do not have a compass, don't worry. You can totally do this without a compass. It's just easier and more accurate when you do use a compass. So I'm going to erase all of my remaining sides. All right. Okay, so we have a 5 centimeter, 7 centimeter, and 9 centimeter triangle. Perfect. Okay, so now if we look at the bottom, given one side and one angle measurement, you can construct many triangles. Given 2 sides and the angle in between, you can construct one triangle. Given 2 angles and a side, you can construct one triangle. Given 3 side lengths, you can construct one, or none, like no triangles, right? So that was example 3 and 4. So you're given 3 side lengths and 3 side lengths. This one we could construct 1 triangle. This one we couldn't construct any because we talked about how these two are not greater than 10 centimeters. They would never meet. And then the remaining, given 3 angle measurements, you can construct many triangles. All right, tomorrow we will talk more about examples 3 and 4 and how we can determine whether or not a triangle is able to be constructed just by looking at the numbers. All right, if you have any questions, please write it down in your WISC and complete the attached Google form. Thanks. See you later.